Hi team, this is another video on Snowflake, and the subject of today is the Snowflake streaming and dynamic tables. It is based on Snowflake quick start reference. You have the link here. So let's start. This enable real-time data pipelines. So we have row sets with Snowpipe streaming, and we have a target table, the staging table, and from this staging table we will derive many dynamic tables, which is a declarative structure. It is so simple to avoid the complexity of the regular pipelines. For the use case, we have a setting of a Java application to stream records and configure connection to Snowflake using key pair authentication. We have a public key and private key. We will run two BAT or SH command just to have the streaming every 10 seconds and the other one every half second. The setting up of Snowflake objects, as usual, we have roles, users, warehouse, views, tables, and mainly dynamic tables. And finally, we will handle the sensitive data using secure function in order to decrypt sensitive fields. This is the whole diagram. So we have two commands, and we have the staging tables. We will, from this staging table, we will derive three dynamic tables for the current, for slowly changing, and a summary. And from summary, we will derive a status table. We will also have regular view accessible in public schema and secure view accessible only for PII role because we will decrypt the order ID field. So let's start the demo. These are the objects in Snowflake: the user, warehouse, role, tables, dynamic tables, and we have three schema: engineering, public, and PII for sensitive data. So let's start. Here we have the Snow site. We'll start the setup. All the scripts used are in the quick start guide. So we need to set up all the required objects. We create some roles, the database, the three schema. This is the initial setup. I'm using also Visual Studio Code with the extension of Snowflake. You can install it and browse Snowflake objects or execute some scripts as you execute them from Snowsite UI. Here, we will wait a little bit. It's a little bit slow compared to this morning. I don't know. Maybe the issue is related to my network. So here, in file, we can here from Visual Studio Code select from streaming table. The table is not created yet. So once created, I will prepare terminal, execute the run bat. So to set up the quick start, I have this folder. I downloaded it. It is a zip file. We have here the command to be executed to stream data to Snowflake. Here I have the key, the private key, to be used to stream, to connect Snowflake and stream the data. Let's see. It is progress. So the staging table has a colon named record content, and it is a variant type. So we'll see after we will parse the content. So the final query successful. If we try to select the content of the table, at least the 10 rows, we have no data. We try to execute the max bat. This will stream 1 million of rows to the target Snowflake database. This morning with my test, it took maybe 15 to 20 seconds. We'll try to check the content of the table. Because it is 10 seconds. Try to check the count. See here we have is a little bit slow. I will pause the video. So here after the pause, it took maybe 1 minute and a half. So we have 1 million of record here. We try select the count from table, should have the same number. So here we have some sample data from, here we have the order ID, which is decrypted. Here we use this syntax just to parse the content of the variant in some field. Check the history. I will skip this. So here we can have, because we can stream from multi-source. Here we have the schema, source schema is prod, and the source table is limit orders. And we will be based on this schema and this table for the streaming. So if we see the channels, we have only one channel for the streaming. If I try to run the slow bat, here we have a streaming each half second. And we can see here that we have another channel now for the slow command. I will just stop it. Let's see. Yes. So here we will create the dynamic tables. This is the first one. This first one, we are using the rank window function just to filter only the last recent record, and we ignore all changes, and we will based on the schema prod and the table limit orders. So let's create the table. It is a dynamic table. It is refreshed each 1 minute and using the compute warehouse. We can check the content. So we have this count. We will have now another dynamic table. It is slowly changing one to keep the history. And as you can see here, we will use the rank function also, and we will have the valid from and valid to. So the valid to, it will be the commit date of the next record, because here we have the rank and we have the descending ordering. Here we try to find an example of order ID with history, because they are random data, they change each patient. So here, as you can see, that you have maybe this is the version 1, the current one, and this is all the history. The version 1, it is insert, and the current history, it could be update or delete this case. So we have the slowly changing. Here we have a summary table. We need only some quantity, so we can, according to our business requirement, create a dynamic table. The lag here is downstream because it will be dependent on the source table. If the source table has been changed, the dynamic table will change dynamically without any issue. So we can create this dynamic table for the summary. Now can have, because I skipped a step, we have also another dynamic table based on the first dynamic table. So we have the stats table. Dynamic table will be based also to the summary dynamic table, and this give us the opportunity to have some cascading dynamic table, and the refresh will be like a tree refresh for the depending objects. If we try to see the stats, we'll see the ticker, the position, and the lowest price and the highest price. It is maybe for analytics purpose. Now we will create a view from the first dynamic table. Here the view is created. Give the grant to public, the content view. For the PII section, we will create a secure view. We have some setup to do here. Control it. We'll create the schema PII, and we'll give the ownership of the schema to this role, and we give the usage on the database, the schema, and some privileges. Then we will create an EDF. It is a secure function that decrypts the content, because the content arrives from the source encrypted for the order ID, I think, and this function will decrypt the content, and this content will be available only for a user with the PII role. Here we create the first function, the second function also to decrypt. This is a test from one order ID, just to see if all is as expected. Then we create another function based the call of the previous one, and we get the right privilege to the system role PII admin, and we have check test here. So here we have the decrypted order ID, and finally we will create the secure view. to decrypt the order ID and grant the required privilege to the authorized role. Here we can check the secure view and see the encrypted colon and the decrypted colon from the decryption done via the function. So here the order encrypted and the order ID with PII, it is decrypted. So it is a sample quick start for the real-time streaming and the dynamic tables. Here I will refresh from Snow side to see that we have also some graphs to see the dependency of the dynamic tables. Therefore, we have here dynamic tables, the current DT in the graph node. We see that it's dependent on the staging table. The SCD is dependent also on the staging table. And the summary, for example, it is dependent on the stats table. It is dependent on the summary table. So here we have the workflow in graph diagram to understand. If we see also the refresh history here from Snow site, we'll see that if it is successful or it is in failure. So as conclusion, we can use the dynamic tables in declarative mode to avoid the complexity of the regular pipelines using Snowpipe, for example, and the streams. And also we have near real-time streaming